button. All right, so we're recording now. All right, so let's see, y'all. So yeah, test one was due Monday. I hope everybody did okay. I haven't even bothered, haven't had, I shouldn't say I haven't bothered. I haven't made time to look to see how all that went. But let's see. So today, y'all, we're gonna do two sections. We're gonna do 8.4 and 8.5. They're not very long sections. The homework, you got about 5, 6 problems on each. It's something like that. It's not a ton of problems, okay? And then I will, I'm probably gonna do it. I don't know if I'm gonna do 2 recordings, y'all. I'll just put it in one, but I'll upload the recording to the playlist. So let's see, let me get the notes going. Where are we? Here we go. Let me open these up. Yes, this is what we want. Let's close that out because we don't need it. Let's go over here and let's see. Is this us? No. Is this us? No. Is this us? No. Is this us? No. Is that us over here? We can do some over here too. Here we go. This is us right here. All righty. Okay, so let me print this to my OneNote and we'll get started. That's what we want. And we'll print it out here. Let's do a little zoom. Pretty much. Well, at least a bunch of them. I need to like go through my OneNotes and I mean, I probably have stuff from a long time ago that I need to get rid of too. But I don't know, for the last couple of weeks I've been putting them all in this one file here. All right. Okay. So y'all, when we were here, what day was it? I guess it was like last Monday. And I'm just going to kind of go back and review a little bit, but let me see if I can find one that's a little bit more simple. And actually, I sent out a video yesterday from one of the questions in 8.3, but let me just kind of zoom in on this part right here. You know, when we were doing 8.3, the partial fraction decomposition, we were basically solving a system of equations, right? And for the most part, we had 2 equations, 2 variables. A couple of times we had 3 equations, 3 variables, and I think there was even one that we did in the notes that had 4 equations, but like some of the variables, like it was already set up, like, oh, we already found out A is 0, or like B is 3, or something like that. It was, you know, pretty simple to set up. But we were basically solving a system of linear equations. What we're actually doing in 8.4, you all, let me see if I can get to 8.4, scroll, here we go. We're going to be solving systems of nonlinear equations. So what we're going to be doing here is we're going to be looking for these 2 equations meet, or they intersect, but both equations are not necessarily lines. What we were doing in 8.3, when we had a system of 2 equations, 2 unknowns, geometrically or visually, what we're doing is we're graphing one line, we're graphing another line, and then we're looking for that point where those 2 lines meet, okay? What we're doing here in 8.4, they're not necessarily going to be lines. They might be ellipses, parabolas, circles, stuff like that, and maybe one of them might be a line too. Okay, so the first one here says solve the nonlinear system of equations by the substitution method. All right. So the other day when we were doing some of these problems, I think it was John that asked, is one method better than another? I don't necessarily think one method is better than another, but like here, it would be a lot more difficult for me to use something like the elimination method, because if you notice, the first equation has x squareds and y squareds, and the second equation only has x's and y's, right? So it'd probably be better for us to do actually substitution. Okay, so what I'm going to do here, I'm going to look at this equation, y'all, and I'm going to decide, do I want to solve that equation for the letter x, or do I want to solve that equation for the letter y? Each one is going to be pretty simple to solve for. So let's take a look here, y'all. If I decided to solve that equation for the letter x, meaning I want to get the letter x by itself, all I'm going to do is I'm going to take this y, and I'm going to move it to the other side. So we're going to end up with x equals y plus 4. Okay. So now that we have that, what we're going to do is we're going to take this value of x and we're going to plug it into the top equation. Okay. So real slowly right here, y'all see how it says x squared, but x is the same thing as y plus 4 squared plus 4y squared equals 16. Okay. So now that I got that part set up, what I need to do is I need to FOIL out or multiply that y plus 4. I need to multiply that whole deal out. So let me go ahead and do that. I'm going to plug this thing in real quick. There we go. Okay. So y plus 4 squared, y'all, I'm just going to write it like this. Y plus 4 times y plus 4, right? And what we're going to do, we're just going to start multiplying this whole deal out. So y and y is y squared. Y times 4 is a 4y. 4 times y is another 4y. And 4 and 4 is 16. Plus 4y squared equals 16. So all we've done really here, y'all, is this part here became that piece right there. And then I just wrote the plus 4y squared equals 16 right over here, right? Okay, so let's keep going. So far we're good at this stage? Okay, so let's keep going here. We're going to start combining like terms. Look, y'all, so we got a y squared and a 4y squared. That's going to give me a 5y squared. 4y and 4y is going to give me an 8y. And plus 16 equals 16. Okay, so do y'all agree that we can do this? We can say, look, let's subtract 16 on both sides. That's going to leave me with 5y squared plus 8y is equal to 0. Okay. And now what I want to do here, I want to solve this equation. Okay, so this is, I'm going to do a little basic factoring. I'm going to factor out a y because I can take a y out of both pieces. And we're left with a 5y plus 8 equals 0. So if you remember this from college algebra, great. If you don't worry about it. There's this rule in college algebra, we usually do with college algebra. It says if you take two numbers and you multiply them together and you get 0, one of those numbers has to be 0, right? So if you close your eyes real tight like Forrest Gump, and you think about, look, I'm telling you right now, I multiplied two numbers together and I got 0. That tells you one of those numbers has to have been 0, right? So what we're going to do, we're going to set each of those parts equal to 0. So I'm going to put y equals 0 and 5y plus 8 equals 0. So here is, this equation here, y'all, is already solved. That one we don't have much to do. When we move this 8 over, it's going to be a 5y equals a negative 8. Divide both sides by 5. And we come up with negative 8/5. Okay. All right. So now we ended up with two values for y. We still need to figure out what our x numbers are. Okay. So I'm going to kind of zoom back out a little bit because somewhere over here, here we go. In red, we know what x is equal to. I'm sorry. Go ahead, John. But remember, there's two answers here, right? Because I'm setting each part equal to 0. This one tells me y equals 0. But what if this part was y was equal to 0, then y would be negative 8 over 5. So remember, think about it this way, John. I'm multiplying two numbers together, and I got 0. That tells me the first number was 0, or the second number was 0, right? So here's the first number being equal to 0. Here's the second number being equal to 0. What would y be from here? And that's what I'm solving. Better? Okay. So y'all, over here, we already knew that x was equal to y plus 4. So look, I'm going to write it right here. X is equal to y plus 4. And now we're going to find our first number. If y is 0, then x equals 0 plus 4, x is equal to 4. So that means that this solution would be the point 4, 0. The x number was 4 when the y number was 0. Okay. I'm going to do the same thing over here. Look, x equals y plus 4. But I know that y is negative 8 over 5. I'm going to think of this as 4 over 1. Okay. Question, between 5 and 1, what's my common denominator? 5. So right here, y'all, we're going to multiply this one by 5 and this one by 5. So that's negative 8 over 5 plus 20 over 5. X is equal to, what is that, 12 over 5? Okay. So then my other solution is 12 over 5 and negative 8 over 5. Okay. So one thing I want to mention here, y'all, and what I like about this problem is that this problem, number one, they were nice enough for us to draw the picture, right? So they drew a picture for us. So that x squared plus 4y squared equals 16, that's the ellipse. That's the thing that looks like a football. And the x minus y equals 4, that is the red line. What we're looking for is where do those two graphs intersect? So look, let's take a look at this one here. It intersects at the point 4, 0. I'm going to zoom in real quick. This point right here, y'all, is the point 4, 0. That's where they intersect, right? Now we had another one, and it was right over here, negative 12 fifths and negative 8 fifths. That is, come on now, that is this point here. Is it negative 12 fifths? Positive 12 fifths and negative 8 fifths, right? So 12 over 5 and negative 8 over 5. And that's where that other point is, right? So I always think it's a good idea visually just to kind of understand what is it I'm trying to do. I'm just trying to find where these two graphs are going to meet up, okay? And they're going to meet up at those 2 points. Now, for every single problem, y'all, you're not going to have to do any graphing at all, okay? And actually, in the homework, the way the homework was set up was the first couple of problems wanted us to do the graphs themselves, and then figure out where they met by doing it like this, what we just did. But we haven't even talked about how to graph ellipses yet. So I figured, I want to ask you how to graph an ellipse if we haven't talked about ellipses. You know what I mean? But visually, this is really what it is we're doing. Okay. All right. What do you think? First problem makes sense so far? We're good? There's 2 right answers. And I circled both of them. This one here and this one here. Remember, John, what is it I'm looking for? I'm looking for the point where the 2 graphs intersect. Where do they intersect? At those 2 points, this one and that one, right? That's where they meet. Okay. So now let's take a look at this next problem. So here I have 2x squared plus 3y squared equals 11, and x squared plus 4y squared equals 8. Okay, so here, y'all, I have a couple of options. We can do substitution again if we want to, or we can do the elimination method. So just to give you a heads up, if I was going to use the elimination method, remember what the elimination method says? The elimination method is I want to get the same numbers either in front of my x squareds in this case, or in front of my y squared in this case, but I want them to have opposite signs. So if one number is 5, I want the other one to be a negative 5. If this one is a negative 3, I want this one to be a positive 3. So if you look at the number in front of the x squared in the first equation, what's the number in front of the x squared in the first equation? 2. So I really want this one down here to be what? A negative 2. Excellent. Okay. So look, I'm just going to rewrite the first equation again. 2x squared plus 3y squared equals 11. And then negative 2x squared minus 8y squared equals negative 16. So, y'all, it's really important that when you distribute that negative 2 that you do it through all pieces, okay? We can't just multiply it by the first term and say we're done. We got to do it to every single piece. All righty. Now, if we do this right, when we add straight down, the x squareds are going to cancel. 3y squared minus 8y squared should give me a negative 5y squared. 11 minus 16 is a negative 5. So now we're going to go ahead and divide both sides by negative 5. So those are going to cancel. That's going to leave me with y squared equals negative 5 divided by negative 5. 1. Okay. What do we need to do to solve for y if it's y squared? What's the opposite of squaring something? Very good. Christian says we're going to take the square root. So y'all, again, I know it's been a little bit of time for some of us. When you take the square root on the right side, remember every number has two square roots. One of them that's positive, one of them that's negative. So the square and the square root cancel each other out, and we come up with two answers. One of them is y equals 1, and the other one is y is equal to negative 1. Because I know the square root of 1 is 1, but I have plus and minus, so I have two answers for y. All right. Here are my two answers for y. If I have two answers for y, y'all, I'm going to end up with two answers for x. Okay. All right. So what I'm going to do is I'm going to use, say, this equation right here. The one right before we multiplied it by negative 2. I'm going to write that down over here on the side. I'm going to clean up some of this other mess because it's kind of bleeding into this one. What's it? X squared plus 4y squared equals 8. Okay. So now what we're going to do, we're going to plug in y equals 1. We're going to plug in y equals negative 1. So let's plug in y equals 1. So that means we're going to have x squared plus 4 times 1 squared equals 8. X squared plus 4 times 1 equals 8. X squared plus 4 equals 8. So x squared equals 4. Okay. So if x squared is equal to 4, what is x equal to? Could it also be negative 2? Okay, so we come up with two answers. X equals 2, x equals negative 2. So I want to point something out here, y'all. Look what we found out. When y is 1, we have two answers for x. We have 2 and negative 2. Okay? Yeah, 2 and negative 2. But I haven't done this one yet, right? I've only just used y equals 1, right? So when we got to this step here, remember what I'm going to do here? Thomas, I'm going to do that plus and minus. So I'm still going to come up with two answers there. Okay, now look, we're going to do the same thing, but now we're going to plug in y equals what number? Okay, let me ask you a question. Is anything really going to change? No, right? Because we're going to have x squared plus 4 times negative 1 squared equals 8, but negative 1 squared is still a positive 1. And so x squared is still equal to 4. So aren't we still going to get two answers here? Okay, so look, now we have another two answers. We have 2 and negative 1, and negative 2 and negative 1. How many answers do we end up with here? 4 answers, right? We came up with a total of 4 answers here, y'all. All right. And again, really what I'm doing here, I'm just looking for the point or points for these two graphs intersect. So again, I'm going to kind of show you something, y'all, just kind of quickly here. Let's see. So we got 2x squared plus 3y squared equals 11. So let me just write that over here on the side. 2x squared plus 3y squared equals 11. And the other one was x squared plus 4y squared is equal to, what was it, 8? Yes. Okay. And so what I'm going to do, y'all, again, I'm going to do this real quickly, but I want to kind of give you an idea of what was happening here. So let's see. So I'm going to go with 1, 2, 3, 4. 1, 2, 3, 4. Okay. Anybody do me a favor? Anybody got a calculator with you? What's the decimal approximation for the square root of 8? Yeah, square root of 8 is, what is it, like 2 point something, 3 point something? Okay, 2.824. So one of them is going to be here, one of them is going to be here. Let's see. What is an approximation for the square root of 2? Is it about 1.4? That's fine. What is the for the square root of 2? Is it about 1.4? 1.4. Okay, so let's go like this and like this. Okay, so what I'm doing here, y'all, this is an ellipse, and all I did is I did a very rough sketch of this graph. Okay, and when we come back to class Monday, y'all, we're going to talk about graphing ellipses, and I'm going to kind of show you what it is I'm doing here, but same kind of idea. Let's see, John, I want you to do me another favor. What is a decimal approximation for 11 over 2 square root of that? So the square root of 11 halves, or square root of 5.5. 2.345? Okay, so one right here and one right about there. Okay, another one, square root of 11 over 3. Square root of 11 over 3? I'm sorry? 1.91. 1.91, maybe right about here and right about here. Okay, so now, okay, it looks a little bit circular, but it's not really a circle. It's more of an ellipse. I want you to look at those two graphs that I drew, y'all. How many points do we have of intersection here? 4 points, right? 1, 2, 3, 4. Come back right here. 1, 2, 3, 4. That's really what it is we're doing. Okay. So again, you don't have to. In the problems, you're not going to have to do the graphs. Okay. Visually, though, I just want you to understand what it is we're doing. Okay. And so maybe y'all remember this back when the very first time you ever solved the system of equations. For the most part, the way we solved the system of equations when you had lines, you might have done this in junior high, you might have done this in high school, you might have done this when you were a freshman here. But the first way we always did it, we would graph the two lines and we'd find the point where they met, right? And then we'd say, okay, this is my solution. This is where the two graphs meet. And then we discovered, hey, you know what? Sometimes that's a pain because you got to draw one line, you got to draw one line, you got to find when they meet. We can do methods like elimination. We can do methods like substitution, and we can find those values algebraically without having to do the graphs. And that's great. And it's always it always goes so much faster than trying to graph them and then look to see where can you find those points. The only thing about doing it algebraically is sometimes conceptually we forget what was it that I was trying to do, or what is it that I'm really doing, and really what I'm doing is I'm just finding the points for these. Okay. So again, I'm just kind of showing you that on the side so that you have an idea mentally of what's happening here. Okay, or visually, I should say. All right. Okay, so let's do another one here. Let me ask you a question. If you were sitting at home or in the library or wherever you were going to do this, and you were doing your homework, and this was a homework problem, what would your approach be? On which equation? Okay, so let's do it to it. Let's multiply the top one by +2. Yeah, some people like it, some people don't. You have options, right? So 2x squared minus xy, or minus 2xy equals 40. The bottom equation is a negative 2x squared plus 3xy equals, what is that, negative 44? Okay, oops, negative, come on now. Negative 44, okay. And so we're going to add these two equations together, right? And what do we end up with? xy, oh, come on, pen. xy equals, what is that? Negative 4? Guys, let me ask you a question. Do we know the value of x? Do we know the value of y? Okay. All right, so you know what I'm going to do? I'm going to say, look, you know what? We were just kidding. We don't want to do this. Because we haven't eliminated either the x or the y. So let me ask you another question. Let's do the same approach that we were doing. But instead of getting rid of, say, the x squareds, is there a way we could get rid of the xy's? We could multiply the top equation by the number 3, right? And we'd end up with 3x squared minus 3xy equals, what's that, 60? And negative 2x squared plus 3xy equals negative 44. And if we decided now to add those two equations together, would we end up with an x squared is equal to what? 60 minus 44 is 16? 16, okay. Okay, so you know that x squared is equal to 16. What are the two answers we're going to get for x? Plus or minus 4. Excellent. Good. X equals positive 4, x equals negative 4. Okay, so now what we need to do, we need to take those numbers and plug them in so we can find our value of y. Okay, so I don't know about you guys, but I kind of like this top equation right here. It just looks a little bit simpler. Look, it's x squared minus xy equals 20. So suppose we plug in x equals 4. So I'm going to go like this. 4 squared minus 4y equals 20. 4 squared is 16. Minus 4y equals 20. So by minus 16 on both sides, that's going to give me negative 4y equals 4. So wouldn't y be equal to negative 1? Okay. So look, we have one answer here, y'all. One of them is 4 and negative 1. Okay. We're going to do exactly the same thing, except now we're going to plug in what number? Negative 4. Okay, so let's see. Is anything going to change? Is it going to stay the same? Negative 4 squared minus a negative 4 with a y equals 20. So let's see. That's 16. Isn't this plus 4y now? Equals 20. So when we subtract 16 on both sides, now we have 4y equals 4. So isn't y equal to 1 from here? Okay. And so our other answer, y'all, is negative 4 and positive 1. You got it. You don't like this part? You never liked this part here? How does it feel so far today? Still don't like it so much? Okay, so let me ask you a question, Christian. What do you feel is the hardest part so far? Let me ask you one thing. Do you not like it because you find it difficult, or do you not like it just because, I don't know, I just don't like doing this part? It's a lot of work. You haven't done it since 10th grade? Yeah. It's funny, y'all, like I said, the last time I told y'all, the last time I taught pre-cal was 2011, what grade were you in 2011? 10 years ago. How old are you today? You're 20, so you were 10 years old back then, so you were elementary school, right? So the last time I'd done pre-cal was 2011, right? And you were what? You were a freshman in high school? Okay. So yeah, but it's funny because um, in college algebra, we do this, or even in like developmental math, we do it, but we only do it with lines, right? We don't do all the parabolas and ellipses, all that kind of stuff. And it's funny because some of those skills that we learned back, freshman year, 10, that kind of stuff, ninth grade, freshman college algebra, whatever it is, if it's been some time and the fact that we don't see it for a little while, you kind of lose some of that ability, or at least it's a little rusty and you kind of just got to try a little bit. Yeah. Yeah, so these problems do take a little bit of time to do, y'all. And again, it's very subjective, right? Some people like it, some people don't. Uh, I can see how, yeah, it's like, especially the problem that we did a little while ago, not this one, but the one we did before, and we had those 4 points, right? So it wasn't just two answers, we ended up getting four answers. But again, visually, we could kind of see what's going on. That's really what we're doing here.
That's the question that they think.
Yeah.
Questions where I can just mess up one little thing and ruin the next 15 minutes of work I have to do.
Oh, trust me, wait till if you haven't taken statistics, man, there's a ton of room of error in statistics. Simply for the reason that like a little while ago, right? When we came up with, what was it, right here, x squared equals 16. And I said, what are the answers? Thomas had with no hesitation, 4 and -4, right? He knew that already. And you know that already because if you think about it, just without even having to mess with your calculator, what number when I square it would give me 16? Well, I know 4 would, but also -4 would, right? The issue is though, and I'm gonna grab my. That's right. And so y'all, when I'm doing like just earlier this week, I was using my calculator app, right? And I was doing it for stats. And you use like a bunch of different functions here, and any small mistake that I enter, like if I type in the wrong number, if I'm supposed to put in 2.38 and for whatever reason, because I got big fingers, I hit the -2.38, or I forget to put the point, something like that, my answer is going to be completely wrong. But whatever comes out on here, we always say, oh, it's la palabra de Dios, right? It's the word of God. You never really question what you get on the calculator. You know what I mean? Like, that's just what it is. So yeah, there's definitely room for error, and we just got to be real cautious as we're doing this. All right, so let's take a look here at the next one, y'all. We got x squared minus 4xy plus 4y squared equals 1, and x equals 4y plus 4. Okay, so for this problem here, y'all, do you think we could do the method we've been doing so far? Could we do elimination? No. This is going to be easier for substitution, right? We can't do elimination because the bottom equation only has x's and y's, and the top one has x squareds and y squared. All right, so look, let's do this. Let's solve the bottom equation for the letter x. It's going to be 4 minus y. And then what we're going to do is we're going to take... And then we're going to take this value of x, and we're going to plug it in everywhere we have an x in the top equation. So I'm going to go super, super slow here. Look, 4 minus y squared minus 4 times x again, which is 4 minus y times another y plus 4y squared is equal to 1. Okay, so before I go on, are we good on how we've done the substitution part so far? This is just the plug part, right? I haven't done anything other than everywhere I had an x, I replaced it with a 4 minus y. Yeah. Definitely. Give me one quick second. So this is both. Mask, a little string. I got one right here. Thank you, though. Appreciate it. So that's the thing. You got a big old head. What? Oh yeah, go ahead. Take your time. Do what you got to do. Okay, so guys, Thomas's question is, what's the idea of substitution? The idea behind substitution is we're going to solve one of the equations either for the letter x or the letter y. And then when whatever answer we get, we're going to substitute that into the other equation. So if you notice what we did here, Thomas, is I solved the bottom equation for the letter x, and now we're substituting that into the top equation. Everywhere we had an x, we're replacing it with that 4 minus y. Okay, so 4 minus y, 4 minus y, and I'm going to do this real quick, y'all. I'm going to think of this as a minus 4y. I just moved the y from here over there. So that's going to give me a negative 16y and a plus 4y squared, and another plus 4y squared equals 1. Okay, so let me go ahead and start pulling this part out. That's 16. That's minus 4y. That's another minus 4y, and that's a plus y squared. All right. So I'm going to start combining some terms over here. Let's see, I'm going to write this as 16 minus 8y, because that's what those give me. Y squared, 4y squared, and another 4y squared is a 9y squared. And then I still have a minus 16y. So far, am I doing okay? Are we good up to this stage? All right, so look, we can still combine some more terms. We can combine this one here and this one here. So that's a 9y squared. That's a minus 24y. And if I subtract 1 on both sides, that's a plus 15 equals 0. Okay. So this 16 right here? Oh, okay. So yeah, so because I had a 1 on this side, I subtracted 1 on both sides, and that gave me a 15. Okay. All right. So guys, at this step, what I'm going to do, I want you to notice that we can divide everything here just to make our numbers a little bit smaller. Can't we divide them all by 3? Okay. So now I have 3y squared minus 8y plus 5 equals 0. Okay, so I'm just doing that just to make my numbers a little bit smaller, a little bit easier to manage. Okay, so at this stage, though, you have two options. We're trying to solve a quadratic equation. This is quadratic because it's a y squared. Anything that has an x squared, y squared, z squared, whatever, quadratic equation. Since it's a y squared, it's telling me I'm going to have two answers, right? Okay, so the two options we have, one is, number one, we can factor. And number two, if you don't want to factor, again, this is a blast from the past for some of us, quadratic formula, okay? So I'm going to factor because this problem here is factorable. And I want to say in your homework problems, they're all factorable, okay? So I'm going to show you how I'm going to factor this in. We're going to use the method of grouping. Grouping says multiply the first number times the last number. So what's 3 times 5? 15. Let's make a list of all the numbers that we know multiply to 15. 1 and 15 and 3 and 5, right? Okay, I'm looking for two numbers, y'all, that multiply to 15, but when I add them together, I'm going to get -8. That's right. Do you agree that we could do this? -3 times -5, that still gives me a positive 15. And when we add them together, we get -8. Okay, so now we're going to start writing each piece. 3y squared. Instead of me writing -8y, I'm going to write -8 using those two numbers. I'm going to write it as -3y minus 5y plus 5 equals 0. And notice, all we did here is we rewrote -8, but using the numbers -3 and -5. Okay? So from here, what can I factor out? What do both pieces have? Not only a y, but a 3, right? So if we take out a 3y, we should be left with y minus 1. Now, over here, these two pieces, what number is common to both? Okay, anytime this one here is negative, whatever number you think about taking out, make sure you take out the negative of that number. So we're going to take out a -5. Now, what's going to happen here, y'all? That's going to change the y minus 1, right? Good, good. You're doing great. Now, you know that we're doing this right, y'all, when this and that match up. If they're exactly the same, we did this right. If they're not exactly the same, I made a mistake, okay? So look, this is going to be y minus 1, and then my other factor are these two parts right here. Okay? We're going to set each of those pieces equal to 0. Y minus 1 equals 0. 3y minus 5 equals 0. So y is equal to 1. And y is equal to 5/3, right? Positive 5/3?
Yeah.
Okay. All right. We got two answers for y. So we're going to figure those numbers in how we have to do it for x. Okay. All right. So look, I'm going to scroll back over here because I want to find my original equation. Here we go. We had x being equal to 4 minus y, didn't we? So x is 4 minus y. So over here on the side, y'all, this is what I'm going to do. I'm going to say, look, if x is 4 minus y, and we do the first one when y is equal to 1, x is going to be equal to 4 minus 1, x is going to be equal to 3. So my first answer is the 0.31. And then we're going to do that a second time. What happens when x is 5/3? Well, x is equal to, I'm going to write it as 4/1 minus 5/3. And everybody agree that my common denominator is the 3? So x is equal to 12/3 minus 5/3. X is 7/3. So then my second answer is 7/3 and 5/3. And there are my two answers. Yeah. Okay, so the factoring method says take the first number and the last number and multiply them together. So 3 times 5, John, gives me 15. Then what I do is I make a list of all the numbers that I know multiply to 15. But I'm looking for the numbers that are going to add up to this one right here, -8. So we said, look, 1 and 15, 3 and 5. Oh, but we're going to use -3 and -5. They still multiply to a positive 15, but they add up to a -8. And then all we do is we rewrite that number -8 using those two numbers. We rewrite it using -3 and -5. So, what's the problem? 3y squared minus 8y equals 5? Okay. All right. So the other method we could use now if we wanted to is this is basically the type of equation we're solving, right? We're solving something that looks like this. Let me ask you a question. Do those stairs compare to me? Look at what I wrote here and look what I have up there. What are my numbers A, B, and C? A is just the numbers in front. What's A? Right? 3, negative 85, right? So the other thing we could do, y'all, and again, I know it's been a long time. We could use the quadratic formula. Okay? And I'm going to strengthen out my medulla oblongata for you, because if you forget the quadratic formula, there's an easy way to remember it. So I asked you guys 10 years ago what were you doing, and Thomas said that was 10. So this would go back even further. Maybe when you were like 1 or 2, maybe even 2 years old. Anybody ever have one of those little tap in the box? Right? You know what I'm talking about? Okay, remember the song Pop Goes the Weasel? Okay. And I sing it to you. Y is equal to negative b plus or minus the square root of b squared minus 4 is all divided by like that. Right? And is it corny? Yes. But I'll tell you what, guys. In the 24 years that I've been teaching, before the pandemic hit, right? Old school style, you got a formula sheet, stuff like that. On data test. You hear everybody doing that, right? Right.
No, it's just
Because
it
it sticks in your mind, right? Okay, so look, this is what we're gonna do. We're gonna use this formula, we're gonna plug in these numbers. Y equals negative, what's my number B? Negative 8. Plus or minus big square root. The number B squared, we said number B was negative 8 squared times 4 times A. A is the number 3 times C, which is 5. All divided by 2 times 3. Okay. So quadratic formula, y'all, is a straight plug and chug formula. All I've done at this step here, I just plugged my numbers in. I didn't try to simplify anything. I didn't go like, oh, negative, negative 8, positive. I just put the numbers there. Now I'm going to start simplifying. Negative of negative 8. What's negative 8 when you square it? 64. 4 times 3 times 5. 60. We wrote over 6. 8 plus or minus, let's see, what's 64 minus 60? 4. All over 6, okay. Y equals 8 plus or minus, what is square root of 4? See? All over 6, okay. Plus or minus means exactly that. One you're gonna plus, one you're gonna minus. What's 8 plus 2? 10. 10 over 6. Can you reduce 10 over 6? 5/3. Okay. One you're going to subtract. What's 8 minus 2? 6. 6 over 6. Can we reduce that? Boom. Tell me, same answers or different answers? What do you think? Did we get the same answers for y? Okay. Which way is easier? That's what you get to decide. If you like factoring, do factoring. If you like the quadratic formula, quadratic formula. Guys, the one thing I will tell you about the quadratic formula is going to work every single time. There's never a doubt. Will it work? Yes. Always, every single time. It's like a master key. It'll open up every one of them. The only thing you got to do, remember the formula? Find your A, B, C, plug and chug, and you're done, right? You don't have to worry about the factoring thing. If you're not good at factoring or you don't remember factoring, quadratic formula every time. You're going to get nice pretty numbers on all these problems too. You won't get anything like, square root of 7 over 3 or something like that. You won't get any rough numbers at all, okay? But you can use the quadratic formula if you want to, all right? It'll still work out. So you do have options in doing them, and then once you get those two numbers, plug them in, find your x values, right? Okay, I think we got one last problem here. X squared minus 6xy plus 9y squared. Okay, so let me write this one. I'm going to rewrite it down here at the bottom just because I'm running out of room. X squared minus, what was it, 6xy plus 9y squared equals, what was it, 0? Yeah, 0. And x minus y equals 2. Okay, so let's do this last problem. Again, we'll go about it the same exact way, y'all. What I'm going to do here, still using substitution, let's solve the second equation for the letter x. Everybody agree that's going to be y plus 2? Okay. Remember what we're going to do. We're going to come back to the top equation, and everywhere we have an x, we're going to replace it with a y plus 2. Okay. So right here, y'all, I'm going to just write it out twice. Y plus 2, y plus 2. All right. I'm going to think of this y right here, y'all, as being right here. Oops. So I can just distribute the 6y like that. So that's a negative 6y squared, and that's a minus 12y plus 9y squared equals 0. Okay. Now let's go ahead and multiply out the y plus 2 and y plus 2. So y squared plus 2y plus 2y plus 4 minus 6y squared minus 12y plus 9y squared equals 0. Okay. All righty. So let's start combining our y squareds. So look, y squared and 9 is how much? 10. 10 minus 6. What's 10 minus 6? 4. Good. So we got a 4y squared. Okay. Oh, let's see. Over here, y'all. 2y and another 2y is a 4y. What's 4 minus 12? Negative 4 minus 12. I have $4. I owe you 12. 8. So a minus 8y. Let's see. Plus 4 is equal to 0. Okay. All right. Let me ask you a question, y'all. Can I divide this equation by something to make my numbers a little smaller? What can we divide them all by? 4, right? We can divide them all by 4. So that's a y squared, a minus 2y, and a plus 1 equals 0. Okay. So again, y'all, when I get to this stage, I have two options. Do I want to factor this thing, or do I want to use the quadratic formula? Okay. So one thing I will tell you, what's different in this factoring problem, and I'm going to scroll back up to the one that we did a little while ago, to this one. What was the number in front of my y squared here? But sorry, the number in front of the y squared though. This number, 3, right? The number in front of the y squared is a 3. When the number in front of the y squared is a 1, these problems are easy breezy cover girl. And I want to show you something. If I come back over here, what's the number in front of my y squared? Okay. These are the easy breezy cover girl problems. This is what you do. What's 1 times 1? 1. We're still going to make our little table. I'm looking for two numbers that multiply to 1, but add up to what number? Negative 2. What two numbers multiply to 1 but add up to negative 2? Negative 1 and there you go. When it's like this, y'all, you can immediately go to this step. Minus 1, minus 1. You can only do that when the number in front of the y squared is a 1. If the number in front of the y squared is 2, 3, 5, 11, then I got to go through the whole grouping process. These are the easy breezy cover governments. Okay, look what we're going to do. We're going to set each part equal to 0. Y minus 1 equals 0. Y is equal to 1. Are we going to get the same thing over here? Okay, so how many answers did we really get for 1? For Y, I'm sorry. Just one answer, right? Okay, so if we know that Y is equal to 1, I'm going to scroll back up here. Remember, we had already solved for X, and we came up with X is equal to Y plus 2. So since X was equal to Y plus 2, and we know that X is equal to 1, X is going to be equal to 3. So our solution here, y'all, is just 1 point, and it's the point. Yeah. I don't know if we. Let me zoom out a little bit so everybody can see the whole deal. So again, y'all, when you're doing those problems and you get to like these last two here, and you get to something that has like a quadratic type thing, again, if you don't feel real strong in factoring, use a quadratic formula. It'll work every single time, okay? And the nice thing about the quadratic formula, it's pretty much foolproof, okay? The one thing I always tell my students is when you're doing the quadratic formula and you find your numbers A, B, and C, when you're plugging those numbers in, don't worry about like, let me try to do a bunch of steps in my head. Just plug the numbers in and then do the next step. Because simplifying something like, again, like the way we wrote it over there on the board, I put negative of negative 8 because the first part says negative B. So I put down my negative and then whatever the number B is. But if you start doing like a bunch of steps in your head just to save some time, yeah, sometimes it works. But when it doesn't, it's because we went too fast, we made a mistake. And one mistake at the beginning is going to mess the whole thing up. So I would say just write the numbers in and then worry about simplifying. Just because, again, trying to save one extra step might end up costing you having to redo the entire problem again. You know what I mean? John, am I good up to here?
Yeah, I'm still, I'm trying to.
All right. So let me pull up the notes, y'all. That was 8.4. Let me pull up the notes for 8.5. That's my mouse. Mm-hmm. So here, okay, and this, and I'll come back to it, John. Okay, so this is what I'm working on here, John. You still need this?
Yeah.
Excuse me.
Yeah.
All right, so John, I'm going to go into the next section, and then we'll come back and we'll figure out what you missed. Okay. That's okay. Take your time, man. You got a lot of time. Don't worry. All right, let's take a look here, y'all. 8.5 is inequalities and systems of inequalities in two variables. Okay, so really what we're going to be doing here, y'all, in 8.5 is we're going to be just drawing some very simple graphs. Most of them are all going to be lines. I think we have one where we have a couple of circles. But everything here, we're just graphing a line. And the way we're going to graph our lines is whatever inequality sign we have, we're going to replace that equality sign with an equals so that we can draw our lines. And then if my inequality is what we call a strict inequality, so it's strictly less than or strictly greater than, when we draw that line, we're going to use a dotted line, okay? And if it's less than or equal to or greater than or equal to, then we'll use a solid line. And then we're going to do something called picking a test point. And I'm going to show you how that kind of stuff works. Okay, so we're going to graph the solution set here. It says y is smaller than 3x minus 2. So step number one now says, let's write the equation. Y equals 3x minus 2. I don't remember if we did this in our class or not. Maybe we did, maybe we didn't. But if we didn't, we're going to go through some stuff that you guys probably did a long time ago. Do y'all remember this equation? This one you got to know because they drill this into our heads for like, I don't know how many years. Y equals mx plus b. That's how we draw a line, right? I'm sorry? It's the equation for a line. Do you remember what m stands for? The slope. Very good. You said it. I heard a couple of y'all say the rise over the run, right? Okay. The point 0 and b, y'all, is what we call our y-intercept. Okay. So let me ask you a question. If we do a little stare compare, look at this equation here. Look at this equation here. What is my m in this case? 3. Everybody agree 3? Now, since we're thinking about a rise over run, why don't we think about it as 3 over 1? Okay. What is our number b? -2. That means that the point 0 and -2 is going to be my y-intercept. Okay. So think about what the y-intercept means. The y-intercept means, remember, the y-axis is the vertical axis, the one that goes up and down, right? What the y-intercept means, though, is where does that line hit this line, hit the y-axis? Well, it hits it at the point 0, -2. So look, I'm going to zoom in here. So I want to find the point 0 and -2. It would be right there. That's the point 0, -2. Now, didn't we say that our m was 3 over 1, I'm sorry? And didn't we call the slope the rise over the run? So again, if you forgot about this, don't worry, we're going to go over it again. Remember what this means? It means we're going to go up 1, 2, 3, and over 1. Okay? Now, what I'm going to do here, y'all, I'm going to connect those two dots. The question is, should I connect them with a solid line or with a dotted line? So take a look here, y'all. If you look at my original problem, my inequality is a strict inequality, meaning it doesn't have the equal to. So if it doesn't have the equal to, then we're going to use what kind of line? Like a dotted line or a dashed line. They call it a dashed line, dotted line. It's the same deal. Okay, so what we're going to do now, we're going to go like this. Okay, there's my line. What we're trying to figure out, y'all, is what we did is we took that plane, we drew a line through it, so we have the left side of the plane and the right side of the plane. We're trying to figure out which is the part that we're actually going to use. So what we do here is we pick a test point. We can pick any point on either side of that plane, and we're going to plug it back into our original equation. I'm going to give you a hint, y'all. You know what point's really easy, breezy, cover goal to pick? That point right there. You've done this before. 0, 0. So this is what we're going to do. We are going to come back to our original problem right here. And everywhere we have an x, we're going to plug a 0. And everywhere we have a y, we're going to plug in a 0. So we're going to go like this. 0, and it's supposed to be less than. I don't know if it is, so I'm going to put a little question mark. 3 times 0 minus 2. So this is 0 is less than 3 times 0 is 0. 0 minus 2 is negative 2. Let me ask you a question. Is 0 smaller than negative 2? No, it isn't. Since the point that we picked, 0, 0, did not work out, that just means that we're on the wrong side. What side do we want? We want this side over here. Okay? And that's the solution that we're looking for. We're taking everything below that line. Okay?
So it is.
If it would have worked, then we would have been in the right side and we would have shaded that area. So excellent question. Look, John, look, y'all. John says, what happens if it would have worked? So let me ask you a question, y'all. Does anybody know what the coordinates of this point here would be? And I'm going to kind of do this so you can see a little bit better. Wouldn't this one be 5 and negative 5? Okay, so based on our picture, we know that that should be the area we're looking at, right? If our equation is y is less than 3x minus 2, remember, this is my x number, this is my y number. So I would say negative 5 should be smaller than 3 times 5 minus 2. So negative 5 should be smaller than 15 minus 2. Negative 5 should be smaller than 13. Yes, it is. And that's why we're in the right area. Does that make sense? So all you're going to do, draw your line, figure out should that line be solid or dotted. If it's a strict inequality, it's going to be dotted. If it has equal to, solid line, and then pick a point. Tell me. Slope-intercept form. Slope-intercept form. Long time, right? But you probably heard it every day in your math class freshman year of high school. There's another called the point slope form. Yeah. So look, y'all, we're going to do the same thing here. There you go. So look, we have 3x minus 2y. Remember, first step equals 6, right? Okay. So if we wanted to do the same thing that we did before, y equals mx plus b, what equation do we need to solve for? Or what letter do we need to solve for? Okay. Y'all agree when I move that 3x over, it becomes a negative 3x plus 6? What should we divide by now? Very good. So y equals a negative over a negative is a positive. Okay. What's my m here, y'all? 3/2. What is our y-intercept? 0 and there you go. Okie dokie. So let's do it to it. 0, negative 3. Okay, so 0, negative 3. 1, 2, 3. Here we go. 3/2 is go back up 3 and to the right 2. Should that line be solid or dotted? Solid. So 1, 2, 3 over 1, 2. We're good? Okay. So look, we're going to connect the dots using a solid line. Okay. All right. What should be a good test point that we pick? Let's pick the same one, 0, 0. Okay. So look, y'all, we're going to pick this point here, 0, 0. I'm going to come back to my original problem, 3x minus 2y smaller than or equal to 6. And everywhere we have an x, we're going to plug in a 0, and everywhere we have a y, we're going to plug in a 0. 3 times 0 minus 2 times 0 is allegedly less than or equal to 6. So 0 minus 0 is less than or equal to 6. Yes, 0 is smaller than 6. This is true. So we are in the right area. We're shading everything above this line. Huh? So pre-cal is basically trig with a little bit of algebra, right? So like those problems that we did last time, the partial fractions, that's a little bit more advanced algebra, right? And this part right here, we don't cover it in college algebra. When I taught in Austin, we actually covered it in one of the remedial math courses. And then we kind of touched on it a little bit in college algebra again. No? 5th grade? Yeah. I mean, we're supposed to do it here. I do it. I think sometimes people don't necessarily get to they don't get to cover all the topics that they want to cover or need to cover or whatever. They did do that?
I think my professor might have, but it's really
Was it a while ago?
it was 2019, but it's like, I don't literally
Don't remember.
thought about math.
Yeah, yeah,
I completely forgot.
yeah.
I remember matrices and stuff.
Yeah.
That,
Like I'm doing
that
that.
was like the last thing. But
Yeah, I'm doing that next week, right? I'm doing that next week in my classes, right? College on, we're doing matrices, right? Think about it. Next week is Thanksgiving, right? So we're going to do that then. The week after that, review for the final. The week after that is the final. So you literally you touch on it at the end of the semester. You know what I mean?
that's the only reason I probably remember.
All right. So let's take a look at these next two, y'all. Graph the solution set. So number 3 and number 4 are actually. I'm going to show you like the easy breezy cover go way of doing these problems. All right. Anytime your equation only involves the letter x, those are vertical lines. Okay, they're going to be a vertical line. So this here, I would graph the line x equals -2. So do y'all agree with me that right here is x equals -2? Now, should that line be solid or dotted? Solid. Okay, we're going to do that. Okay. For these problems, y'all, you really don't have to do the whole test point thing. You can, but you don't necessarily need to. Look at the direction of the inequality. If the inequality is saying it's smaller than, would that be to the left or would that be to the right? Okay, shade it. Okay. We're going to do the same thing here. Okay, so look at the next one. First I'm going to do, y'all, y equals 3. These are horizontal lines. Okay, y equals 3. Everybody agree? 1, 2, 3, right here. Dotted. Okay. And then look at the inequality. Y is bigger than 3. Would that be above or would that be below? Above. So we're going to shade above. And you got it. Take it away. Okay. So now let me scroll to the next couple of problems that we got here. Okay, so we got 2 more problems, y'all. So look, for number 8, we can keep doing that whole y equals mx plus b, but we don't absolutely need to. Let me show you another way to do these lines. So look, the first line we have is 3x plus y equals -3, right? Okay, there's another way to graph the lines, y'all, that I think when the equation is in this form, like ax plus by equals c, so the x and y's are on one side, the numbers on the other, we can find the intercepts. This is the intercept method. We're going to make a little chart. Oops. And this is what we're going to do. We're going to figure out what happens when the x value is equal to 0. Okay? So look, if I plugged in a 0 for x, 3 times 0 plus y equals -3, do you agree that piece just goes away? What's y equal to? -3. Okay. All right, now I'm going to do the same thing, but I'm going to put the 0 where the y used to be. So 3x plus 0 equals -3. That goes away. What would x be equal to? Okay. Now I'm going to ask you to do me a favor. Let's plot those 2 points. Where would I find the point 0 and -3? Would it be up, down, left, right? X is 0, y is -3. From the middle, we go down 1, 2, 3. Okay. Look at the next one. -1, 0. When x is -1, y is 0, do you agree the left one spot? Right there? Okay, second question. Look at the original equation we had, or inequality we had. Solid or dotted line? Solid line, let's do it. All right, so now we're going to do the same thing we did before, y'all. We are going to do our test point. Can we still use 0, 0? Okay, let's use 0, 0. So what we're going to do, we're going to put 3 times 0 plus 0 is bigger than negative 3. So 3 times 0 is 0, plus 0 is still 0. Is 0 bigger than or equal to negative 3? What do you think? It's not bigger? 0 is not bigger than negative 3? Yeah, it is, right? So think about it this way. If I say, hey, let's go get some lunch, and we go to the ATM, and I do a balance check, and I have $0, and yours balance says negative 3, guess what? We're not eating, but I got more money than you, because I don't know the bank anything, right? You still owe $3. Okay, so look, 0, 0 worked. So I'm going to shade where the 0, 0 is. It's above this line. Okay. Let me keep doing it over here too. All right, y'all, we're going to do the same thing for the second line. X plus 2y equals 4. So let's make that same little chart that we made a little while ago. Okay. All right. So let's take a look here. If x was equal to 0, 0 plus 2y equals 4, what would y be equal to? 2, good. So I'm going to put a 2 right there. Okay. And then we're going to put the 2 where the y used to be. So x plus 2 times 0 equals 4. That goes away. Everybody agree x is equal to 4? Okay. So now let's plot those points. Where would I find the point 0 and 2? Would that be up, down, left, or right? X is 0, y is 2. Up, 1, 2. Okay. And then what about the point 4, 0? To the right, 4. 1, 2, 3, 4. Okay. Second question here, y'all. When I connect those two green dots, dotted. Okay. Okay, there's my dotted green line. Okay, so now what I'm going to do, can we use 0, 0 again? Let's use 0, 0 again. So we're going to come back to this inequality, x plus 2y is smaller than 4, and we're going to use the point 0, 0. So 0 plus 2 times 0 is smaller than 4. Is 0 smaller than 4? Yes, it is. So what I'm going to do is, from the green line, I'm going to shade everything smaller than that, everything below that line. Okay, now I know it looks a little bit messy. What do you think we're looking for? The middle part. Where did we double shade? So check this out, y'all. This is what we're going to do. Those lines meet somewhere right about here. This line is solid. This line here is dotted. And we're looking for everything in this area. And that's our solution set. Looks like a Christmas tree, doesn't it? Feliz Navidad. I'm sorry, say it again? No, because remember, the lines go forever and ever, right? So no, because think about it this way. So I'm just going to kind of do this over here on the side real quick. But like, this is what it looks like, right? We got something like this. So even if I have a line that goes over here, isn't it already dipping into that quadrant? You see what I mean? And it's already dipping into this quadrant over here too. Now it won't be in this one, but it'll be in, it could be in 3 of them, right? Well, there might be certain restrictions, but like so far, these problems, that's really all they're asking you to do. And again, all you're looking for, guys, is where did we double shade, right? What's the part that we double shaded? All right. So we got one last problem here. And it's this one down here. And there's the graph all the way down there. I don't know why it came out so low, but it's all right. We can figure it out. All right. So first thing I'm going to do here Okay, so we have an equation when it's centered at the 0, 0. The equation of a circle, y'all, is always in the form x squared plus y squared equals r squared. Okay, that formula looks kind of familiar, didn't it? Did we been doing that earlier in the semester with all the trig stuff? Okay, r stands for the radius. So first thing I'm going to do here, I'm going to look at the first equation or first inequality that we have. X squared plus y squared is greater than or equal to 9. Okay, so the first thing I do here, I'm going to write the equation. X squared plus y squared equals 9. So number one, this is an equation of a circle. What would the radius here be? Well, think about it this way. The last number is the radius being squared. So what number did we have to square to get to 9? 3. Okay. So what I'm going to do is I'm going to draw a circle centered at the origin with a radius of 3. So let me ask you a question, y'all. If you know that our circle is centered at the origin with a radius of 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. Wouldn't it have those points at the end? Because I'm just going 3 up, 3 down, 3 left, 3 right. Okay, second question. Should my circle be solid or dotted? Solid, right? Because it has the equal to part. So I go like this. Boom. There's my circle. Okay. All right. Now, we're going to pick our test point. Can we use 0, 0? Let's do it. Oops. 0 squared plus 0 squared is bigger than or equal to 9. Bigger than or equal to. Is that true? Is 0 bigger than or equal to 9? No, it isn't. So what do we want? We don't want inside the circle. We want where? Outside the circle. Okay. There we go. Okay. Because look at the formula. The last number is the radius being what? Being squared, right? So what number one do I got to square to give me 9? I got to square 3, right? Okay. So now I'm going to write down the second equation of the circle we have. We have x squared plus y squared is smaller than or equal to 16. Okay, so let me do that over here, y'all. X squared plus y squared is smaller than or equal to 16. So I'm going to write out the equation first. I'm going to put the equals first. What is my radius here? Radius is 4. Very good. Everybody agree radius is 4? Because again, what number do I got to square to give me 16? 4. Okay, so I'm going to come back over here, and I'm going to go 4. So I'm just going to basically go 1 point out further from where we were. Okay. Second question, when I connect those 4 points from my circle, solid or dotted? Solid. Give me a solid, man. Okay. All right, let's pick our test point being 0, 0 again. So 0 squared plus 0 squared is smaller than or equal to 16. Is 0 smaller than 16? What do you think? Yes, it is. So from the blue circle, we want to shade everything what? Inside or outside? Inside. Everything inside the blue circle. All right. I know it's pretty messy there. What do you think we're looking for? What part did we double shade? Anybody know? In between both of them. Didn't we shade this part right here twice? And there's the answer. And that's what we're looking for. That was the last one. So y'all, the next section in chapter, we don't do the next section in chapter 8. The next section, chapter 8, is something called linear programming, and sometimes they call it optimization. And this is when you do this idea of shading, but you, a lot of times it's applied like in engineering models, in business models and stuff like that. And then what you're doing is you're looking at certain points to kind of either maximize, like say you're trying to maximize production, or you're trying to minimize costs. You do a lot of this where you're solving this system of inequality. And earlier, Kristen had asked something about like, is it possible it's only been in one quadrant? Thomas said we put restrictions. So a lot of times, like especially in business models, say you're producing, I don't know, you're making cell phones or you're making ear pods or something like that. You can't make negative ear pods, right? So you're either going to make some or you're not going to make any, which tells me that my X number is going to be positive. So that already tells me, look, I'm looking at my X values only where I'm positive. So I'm only looking at quadrants 1 and 4, stuff like that, right? I obviously don't want my cost to be negative because that means I'm losing money, right? Or my revenue, I'm sorry, to be negative because it means I'm losing money. So then my Y values are positive. So now you start looking at stuff in quadrant 1. And when you draw 2 lines, you find, like, say, a point up here, a point over here, and then a point where they meet, and you find out which is the one that's going to maximize either maximize my production or minimize my cost, stuff like that, okay? But that's kind of where it's applied. I don't know why we don't do it, because what's the point of learning this if we don't actually apply it? But we might see some of that in Calculus 1 or something like that. But anywho, this is what 8.4 and 8.5 are, okay? So guys, just to give you a heads up, my other mouse isn't working, but let me do this real quick. Let's see. Let me stop recording because that is all for today.